Electrical circuit. Now, what do you mean by electrical circuit? Electrical circuit is a circuit in which there are conducting elements. Conducting elements we can consider the battery, the resistance, we can also have the capacitance, inductance in the circuit. But for at this present, we will use only resistance and battery. This is the resistance and this. So this circuit is a network in which there is a connection of battery, which is the source, and the resistances. Now the network can be of two types. One is the active and another is the passive. Active means is this circuit which has got the battery. This will be the active circuit. This is a battery. This is active circuit. And here there is no battery. So this is a passive circuit. So it consists of active as well as passive elements. This element, resistance is a passive element, and EMF battery, which EMF is E, is active element. Now what do you mean by the branch? This is the electrical circuit, and there is a one branch. This is another branch. So branch is a part of the network in which current is constant. So here the current is I1. This is constant. Here is I2. Here is I3. So this is one branch. This is also one. This is another branch. This is totally the one branch, because there is no other connection. So this is AB, this is also branch, this is also branch, this is also branch, this is also. So these are branches. Now what is the nodes? Nodes, here it is a one node and this is another node. Here this is also node. So node is a point where more than two or more than two branches meet. Here this branch, so this is a node. Here this branch, this is a node. Here this branch, this is a node. Here also this branch, this is a. So node is a point of intersection between the branches. There may be two branches or three branches where meet, that point is a node point. Now what do you mean by closed loop? Closed loop means if we start from one point and end at the same point. If we start from A, then B to C to D and this way. So this will be a closed loop. This is also a closed loop. This is start from here, here to here, here to here. This is also a loop, here to here, here to here. So closed loop, we start from the same point and at the same point, that will be the closed loop. So these are some definitions which are important for electrical circuit. Now earlier we have studied the series and parallel combination and their mixed combination. In that combination we can find the current in the circuit. That circuits were easy or simple circuit. In that circuit there was only one source and the resistances are either in series or in parallel. But here, as we say, here are the two batteries. So we cannot use the Ohm's law to find the current in the circuit or potential difference here. It is not possible. So when the circuits are complex circuits, then we cannot use the Ohm's law or the combination of series and parallel, but we will use a Kirchhoff's law. Now Kirchhoff's laws, there are two types of Kirchhoff's law. One is the Kirchhoff's current law and Kirchhoff's voltage law. Now Kirchhoff, he gave the idea and a method to solve the complex electrical circuit. Now first law is current law, or we can call it KCL. Kirchhoff's current law. Now according to this law, if this is a node, this will be node here, one current is here, one current is here. So here I1 current is approaching to this point, I2 is going outward, I3 is going outward, and I4 is coming out. So here it will depend the total current at this point, at this junction will be equal to 0. We will consider either the incoming current positive and outgoing current negative, or we can consider incoming current negative and outgoing current is negative. So the summation of current at this junction will be equal to 0. This is based on the principle of conservation of charge. Now principle of conservation of charge says that the total charge remains constant. But here the charge is not stationary. In the case of electrostatic, the charges were stationary. So we can accumulate the charge. But here there is a dynamics of charge. The electrons are not stationary. They are moving and they are moving, so they make a current. So the incoming current will be equal to outgoing current. So by the current law, if I1 total here, I1 positive, I2 we take negative, I3 we take negative, it is going outward, and I4 is coming. So I1 minus I2 minus I3 plus I4 is equal to 0. Or we can write I1 plus I4, we take this is equal to I2 plus I4. So we can also say that total algebraic sum of the input current will be equal to total algebraic sum of outgoing current. Incoming currents are I1 and I4. So I1, this is the total algebraic sum of input current, and I2 and I3 they are going outward. So the input total algebraic sum of the input current I1 plus I4, this will be equal to outgoing current I3 plus I2. So this is the Kirchhoff's law. Now Kirchhoff's law is based on the conservation of charge. Now as we have learned earlier, the charge is always conserved. We cannot destroy the charge or we can create the charge. Total charge will be constant. Here the charge is moving, then we will say the total charge coming per second will be equal to total charge going outside. So this is your first law, which is known as the KCL or Kirchhoff current law, and according to this law, we can say simplify it that the algebraic sum of input current will be equal to algebraic sum of outgoing current, because current is a scalar quantity. So it is a scalarly added or scalarly added, which are coming and which are going. Now second law is Kirchhoff's voltage law. We can call it KVL, Kirchhoff voltage law, KVL. Now KVL is based on the conservation of energy. Suppose we want to put a thing from here to here. Suppose this is the 20 step, and a person goes from here to there, he will consume energy and he will go to from this foot of this and then he return back. Suppose 10 step, then 7 step, and then 3 step. Then he started from this point A and ended at the same. Means the total energy here it was the positive, and here it is decreasing. Sum of the energy here will be equal to, suppose we take that it is 100 joule energy consumed to bring from A to this point B. When it return to this part B to A, then the total energy will be lost, will be also equal to 100. So in the same way, we have in the circuit battery is a source of energy, and the resistances are consumption of energy. So total energy will be conserved. So here we take the for any closed, we take any closed. This is the one of the closed loop. We take any closed loop, then the sum of potential will be equal to 0. So we can say sum of potential V will be equal to 0. Now here we can consider loop. Loop can be either clockwise or anti-clockwise. We can take clockwise or anti. It makes no difference. If we take clockwise or anti-clockwise, it makes. So this is a complete loop. So for a complete loop, the summation of voltage will be equal to 0. Now, what will be the, suppose this is the direction of loop and this is the cell, and to cell it is a positive and this is the negative. This point is at a higher potential, this is at a, so when we go from higher to low means the energy is decreasing, so we will take minus E. EMF will be minus E. Now second case, when we are going from minus to plus, this is the direction of loop and it is going from lower to high, then here the EMF will be positive. Now we take the combination of these two. Here there is one cell, another cell, and the direction of loop is this. Then here is a positive, so it is higher, so minus E1, and here also positive, so minus. So here the total EMF will be equal to minus E1 minus E2. Now in this case, suppose this is a minus here, plus here, minus here. So here is a less, going to higher. So then E1 will be positive, minus it is negative because it is going from higher to lower. So here, if the direction of loop is this, then it will be equal to E1 minus E2. This will be total. Now for the potential difference. Now, if the resistance is this and current is passing through in this direction, then the potential drop will be equal to I into R. In this direction. So there is a potential drop. So we will take it minus I into R. We will take minus I into R here. Now in this case, second case, here we take the resistance and current is, our direction of loop is this and current is opposite. So here it is the higher end, it is the lower end. So it will go from lower to high. Then this IR will be positive. So IR will be positive if we go from lower to higher, and it will be negative IR when we go higher to. So this is the one way of representation of the sign convention for EMF and potential difference. We will use this for this circuit. We take this circuit. In this circuit, here there is a battery of 12 volt, the resistance of 5 ohm and conducted here, and here resistance of 2 ohm, here again battery of 6 volt and 3 ohm resistance connected here and like this. So this is the circuit, and such type of circuit cannot be solved by the Ohm's law or series or parallel combination. So we will use the Kirchhoff law. We will take the two loops. One loop is A, B, C, D. So this is anti-clockwise. This is the L1 and it is anti-clockwise. Here we take, suppose this is also we take the anti-clockwise. This is the L2, loop number 2. So we will consider, we can have closed circuit loop. We can have one loop this, another loop is this, and we can also take third loop is this. So A, B, C, D, A. It is a closed loop. Similarly, C, D, E, F, T. This is also closed loop. So we can apply here the Kirchhoff's law. First we take, suppose the current from this 12 battery is I1 and I1 is flowing in this direction. This is the junction. Here from this battery the current is I2. It is also in this direction. So here it is I2. Here is I1. I1 and I2, they are approaching towards the point C. Then by the Kirchhoff current law, the outgoing current will be sum of these I1 plus I2. So current here in this branch CD will be equal to I1 plus I2. So we consider here this method where summation of V is equal to 0 and write the equation for two loops. First we take D, E, F, E, D loop. We start from here, then we start from here, suppose here. So we start from here. So here when it is a minus, so it is lower potential, so it will be 12 positive. EMF will be equal to 12 positive. Then here higher to lower, so here there will be a potential drop where will go to 5 into I1, and here again there is a potential drop, the minus ohm, 2 ohm multiplied by I1 plus I2, the current is and this will be equal to 0. So we solve it, 12 is equal to 7I plus 2I2, we solve it. Then if we take then another loop A, B, C, D, A. In this loop we start from here. Then it is a minus, so it will be plus 6 volt. Then potential drop will be 3 into the current is I2, so minus 3 into I2. Here also the direction of loop is this and current is also in the direction, so it will be minus 2 into I1 plus I2. This will be equal to 0. So if we solve it, it will be 6 is equal to 5I2 plus 2I1 is equal. So these are two equations and we are having two unknowns, I1 and I2. We can solve it. And we will find that I1 will be equal to 48/31 ampere. I2 will be equal to 18/31 ampere. And in this branch, CD branch, what will be the current? It will be sum of I1 plus I2. Add kar lo. Then it will be equal to 66/31 ampere. So in this way we can find the current in values of current I1, I2 and I1 plus I2. This is the one method. We can say we can have a alternate method also, and we take the alternate method in which we will say the summation of EMF will be equal to summation of potential difference. Now here the summation of EM will be have the same convention as we have taken here. It will go from positive to negative, then it is negative. It goes from negative to positive, it will be positive. And for resistance it will be different. If we go from here to here, suppose we take here, the current is this side and L is also this direction, then this will be IR will be positive here. Here it was negative. Here when current is in this direction and L is in the opposite direction, then it will become minus I into R1. Now if we take this convention and we can write from D, E, F, C, D, this loop. C, D, E, F, this loop. We start from here. Then it will be equal to 5I1 plus 5I. Distance current, the loop direction is this, direction of loop is this, and current is also there. So it will be equal to 5I1, and here come it, the current direction is this, and loop direction is also there. So it will be equal to 2 into I1 plus I2. And this is equal to, now here it enters at minus sign. So it is 12V. So 5I1 plus 2I1 plus I2 will be equal to 12. So 7I1 plus 2I2 is equal to, this equation is same as this equation. There is no difference. You can take this method or this method. It makes no difference. Now for this ABCD loop, from this loop, we started, then 3I2. Here start from 3I2 and directional loop is also same. So 2 into I1 plus I2. This will be equal to, now it entered from negative. So it is plus 6. So this will be equal to plus 6. And we solve it, then 2I1 plus 5I2 is equal to 6. This is the same equation. So if we can take this method also, we can have this method also. Both methods are suitable. And there are other ones also. But I am discussing only two methods by which we can solve this electrical circuit. Now